Okay, next problem. It's classic. A ladder 20 feet long leans against a vertical building. If the bottom of the ladder slides away from the building horizontally at a rate of 3 feet per second, how fast is the ladder sliding down the building when the ladder is 8 feet from the ground? This is a classic related rate problem. When we talk about these triangle problems like this, you get to make the assumption that all buildings are perfectly vertical and all ground is perfectly horizontal. And so you're always going to have a right triangle. So my picture here, I've got a ladder leaning against a perfectly vertical building against perfectly horizontal ground. I've got a ladder leaning against it. So there's my ladder. That ladder is 20 feet long, and I'm going to put it in the picture because that is not subject to change. That ladder is not stretching and shrinking. The ladder stays the same. Any quantity that is not subject to change can go in the picture, and that will make your life so much easier if you put into the picture the quantities that are not subject to change. You can't put in the quantities that are subject to change, but please do put in the quantities that are not subject to change. So we've got a vertical ladder leans against a building. So there's my picture. Then it says if the bottom slides away, so this bottom starts to move. And so this side is going to change. I'm going to call it X. So the bottom slides away horizontally at a rate of 3 feet per second. How fast is the ladder sliding down? So this side is coming down, that side is changing. So I'm going to give it a name, Y. Then in the end it says this is how fast is the ladder sliding down when the top of the ladder is 8 feet from the ground. So there's my picture. Now saying what each phrase meant. So a ladder 20 feet long leans against a vertical building. That gave me the picture. If the bottom slides away from the building horizontally at a rate of 3 feet per second, bottom slides at 3 feet per second, well, that's a rate. The bottom I labeled X, and so I get dx dt, didn't leave my right? I get dx dt equals 3. And now, hugely important, I have said what x is, and now I see an x over here. If you don't tell me what x is, and you just write over here dx dt equals 3, you've told me nothing. You must tell me what your variables mean. If you don't tell me what your variables mean, and it's good enough just to give me a picture where you very clearly labeled what each variable means in the picture, x is the bottom of that triangle, then I know what dx dt is. But if this x isn't there, I don't know what this means, and if I don't know what this means, your work is meaningless. You've got to label your pictures with variables. So we have slides horizontally at 3 feet per second. How fast is the ladder sliding down? Well, that would be find dy dt. Ladder sliding down. They're talking about this side. And again, I have told my reader what y is, so when I say find dy dt, that makes sense. No y, if there's no y over there, you don't know what that means. And then lastly, when top is 8 feet from the ground, that would be when y equals 8. And so there's my setup. Step 4, we now need an equation that relates a right triangle and its sides. And that would be the Pythagorean theorem. So the way I have my picture labeled, x squared plus y squared equals 20 squared, or that's x squared plus y squared equals 400. And like I said before, if you can get to this point, you can probably finish the problem because the steps are pretty much the same from here on out. It's the setup that varies each time. So step 5, implicitly differentiate with respect to t. And so that's going to give me 2x dx dt plus 2y dy dt equals 0. We differentiate each variable with my normal rules, but since it's implicit with respect to t, every variable gets followed by its derivative, in this case dx dt or dy dt. Now in this particular one, I can make life a little simpler, and I'll go ahead and do this. Simplify, divide all terms by 2. And that would is not a step that you have to do, but since everybody is divisible by 2, I can go ahead and do that. Step 6, substitute in known values. So we had, and I forget what we had. Let me check what we had. We had that dx dt was 3. And it was when y equals 8. So I'm going to have x times 3 plus 8 dy dt equals 0. Okay, let's recall that we want to find dy dt. And so unlike the previous problem where, boom, I was essentially done, we still need the value of x when y equals 8. We don't quite have enough information, and sometimes this will happen. And so now we've got to find that value. So to find x when y equals 8, we're going to use the picture. So this was my picture. This was x, that was y. Well, we now know specifically that y is 8. And so that tells me x squared plus 8 squared equals 20 squared. X squared plus 64 equals 400. X squared equals, I should be able to do that in my head, but we'll ask the calculator, 336. And so x equals the square root of 336. I care not if you simplify that square root or not. My lab math would simplify it, so simplify it for my lab math. Don't write me and say I didn't simplify it. I'm telling you, go ahead and simplify it. That's just algebra, basic algebra. But I don't care if you simplify it, so I'm not going to bother simplifying it. Now notice I did not take a plus or minus here. That was not an oversight. X is a distance. So this is not a plus or minus situation, but if I was just solving any other generic equation where x could be a negative value, I would have a plus or minus. So let's finish what we were starting. We were substituting in. We substituted in, we came to a roadblock. We needed to have x. So we had 3x plus 8 dy dt equals 0. Well, we now know what x is. So 3 square root of 336 plus 8 dy dt equals 0. And so finally, step 7, solve in this case for dy dt. And so I'm going to get 8 dy dt equals -3 square root of 336. And so dy dt equals -3 square root of 336 all over 8. Now, while I don't care that you simplify that radical, please don't tell me what decimal it is. Now, on some of the homework, MyLab Math may tell you to give a decimal, and if MyLab Math tells you to give a decimal, well then give a decimal. But never give me a decimal unless I gave you decimals. And so there is this problem. And that's where we will end this video.